Mr. P. Surya Prakash is an eminent engineer, consultant and a mentor who has made significant contribution in the civil engineering sphere. After completing his MS in Structural Engineering from IIT Madras and work experience as design engineer for 6 years, he established Satyavani Projects and Consultants Private Limited. For the past 3.5 decades, the firm has executed multidisciplinary projects in India and internationally and has emerged as the nation's premier civil structural, architectural, MEP and project management consultants. Put your hands together, everyone together, as I take the opportunity to invite forward none other than Mr. P. Surya Prakash.
Good evening to all the delegates from all over the country and executives of Tata Group. It's my honor and privilege to be among you today to share some of my experiences in the last 3.5 decades as introduced. So today I chose this theme of forms of future with the construction stakeholders to be in line with the theme of the evening. And I'm going to share some of the projects that we have executed in the last 3.5 decades as an engineer. And I'll also talk about, apart from the forms, we also talk about the time and cost aspects of the project. And as we are aware, sustainability is the compulsory thing. And in some of the projects, what we have incorporated in sustainability also I try to cover with the limited time available. I try to do as much as possible. So shaping is synonymous to form in our construction, that is technology. While we talk about the shape or form, we have to also consider the technology, construction, resources and the skill availability. And the new future is responsible construction in the present theme of the sustainability. The time, cost, sustainable built environment, green buildings, and towards net zero. In fact, these are all the very responsible construction themes. Actually, one has to consider particularly the professionals we are and engineers who are constructing. And together, we are all the stakeholders actually who are involved in planning, design, engineering, procurement, supply, and construction. Now we have the technology in our hands. We have building information modeling in 3D, 4D, 5D, 6D, and 7D. Of course, in India, still we have to incorporate 7D expertise, though it's available abroad. 7D is nothing but the operation and maintenance facility management, wherein actually if you see the sustainability aspects, we need to incorporate more in the facility management basically, because the construction contributes only 40% of the carbon emission or energy consumption, while 60% of the life cycle energy and carbon emission are during the facility management. 3D printing technology which is emerging, of course it is in very nascent stage, but definitely offers many solutions in future. So we have to look at the 3D printing technology also for the sustainable construction in future. The augmented reality, this is also emerging and very handy for particularly the professionals. If you look at me as an engineer, with all my experience, if I have to visit 5 sites in a day, it is humanly impossible. At the most, I travel for 3-4 hours, go to the site, spend 2-3 hours at the site, that's all, day is over. But with augmented reality, we can, sitting in my office, can inspect at least 5-6 sites, hourly one site using this technology, and it's also emerging very fast, and it will be very useful not only in planning but also during construction. Next is the 3D modeling, the building information modeling that we talked about, particularly for steel construction. I have been working in the last almost 38 years, 35 years, where we used to make the drawings in tracing sheets. I started from there my career. I know how much steel used to be wasted because of the errors in the drafting or 2D to 3D conversion. And now we have the 3D modeling, which is very handy, with which we can use from starting from planning to detail design, detailing, delivery, fabrication, erection, all the stages. We have this software, so we can schedule even the dispatch of the elements in a sequence that we don't lose time on the side, and we don't waste the energy in loading, unloading, shifting, and all these aspects. So this is a very handy technology that is available to us. Now, the future. The recyclable unique forms. This is actually I was in Norway last year attending FIB Congress, where the technology in R&D stage that is developed is to develop the form work without the sacrificial form actually. We know how much we are wasting the resources, whether it is steel form, aluminum form or wooden form. We use the form work necessarily for concrete. And now there is a development in which you can reuse the form material like sand with chemical, and you can design the shapes optimally for the structural forms actually. So you can see the complex shape that is here. You can develop any form with the mathematical modeling, which is most optimal. You know, we all know optimal is utilization of the material capacity to its bring in all the elements, and that is optimal shape. And to make that shape, so far we have been thinking twice to use such forms because of the form work. Now we have the 3D printed kind of form work which can be reused again. You can again melt it and reuse the form, and this is the most advanced thing that is going to happen in the near future. And apart from that, we also know the partial safety factors that we use in the design. Also, we are having the algorithms to develop the partial safety factors considering the quality of construction. It's not a fixed partial safety factor. The uncertainties in loading, form or material, everything can be modeled mathematically and we can arrive at the most practical. That means so far we were not having, if L&T does the contract or some small contractor does the contract, if you use precast construction or use the normal wooden formwork, there is no change in the partial safety factors. Whereas now we have the codes that are coming up, model code, where you can take the partial safety factors to suit the type of construction, to suit the type of material that we are using. So this is my brief background about today's talk. And I'm going to share whatever projects that we have done and we are doing right now, just to take you to the scale of the projects that are happening, particularly even in Hyderabad. I come from Hyderabad, so this is the first phase of the project where 10 million square feet is constructed in 25 acres in 40 floors with 5 levels of parking, to be completed in 3 years. We are having developers who are delivering 15 million square feet every year. This is the scale of the construction that is happening, and so we have to be geared up with the technology and solutions for that kind of challenges. And this is every project that we talk about is 40 floors and 1 million square feet is the norm of the day nowadays in the projects, because it gives the scale of the economy. And this is a project we completed about 15 years back, a 30-story building construction, wherein we could economize considering the form. Nowadays, we all know high-rise buildings, we are forced to have transfer slab or transfer girders at the parking level. Whereas in this project, we have insisted on taking the shear walls to the parking level and planned the parking to suit the flats above, because 30 floors should dictate the structural system, not the 4 floors of parking. So with this, we could economize drastically in this case. And this is a 20-story construction with a IGBC gold rating completed in 20 months construction. And this is a very unique project that we have done for affordable housing in Telangana. It's by government actually. 4,000 houses to be constructed in 12 months at a cost of 1,285 rupees. So time and cost are fixed in 11 floors, wherein this is the first project probably in Asia, where in the same project we use 3 technologies. One is conventional, one is precast, one is rigid monolithic construction. This we have adopted because when you have time and cost fixed, you have to have technology neutral. This is what we got with GEO, and within the same project, out of 37 towers, we have done 15 towers in conventional, 14 towers in precast, and 8 towers in rigid monolithic construction. And we completed in time, and we completed within the cost, without any cost escalation within 12 months. And this is the large scale construction that we have done for the defense housing in different cities like Bangalore, Chennai, Hyderabad, Bihar, and 39 locations. This is another type of project where we had to handle the risk of delivery. And finally, it was a delayed project, but we delivered with risk and cost contract. So that kind of challenges also. This is another phase 3, again housing with the high-rise construction, wherein we made the client to change the technology to precast and rigid monolithic construction in defense. About 8,000 crores project we converted using the technology, and DPR we have submitted. This is another residential project where 15 floors we could design with the steel consumption as less as 3 kg per square feet. This from the planning, this is lean construction project where we have used the rigid monolithic construction. These are normal residential towers where we have 3 parking and 16 floors with the transfer girders, where the steel consumption has gone up very high. Though Bangalore, this is in Bangalore actually, though Bangalore has less wind and less earthquake risk, but still, just because of the transfer girders, the steel consumption has doubled in a less number of floors for the same one. This is a regular 10-storied conventional construction, and this is the first rigid monolithic construction project in Hyderabad, wherein we have used aluminum form for a low-cost construction about 10-15 years back at a cost of 750 rupees per square feet. That is the cost optimization we did, but with better quality than any affordable house. And here, this project, very important thing where we have used the monostrand in post tension. We have the post tensioning wherein we have to have a minimum slag thickness of 160 mm or 175 mm. So to reduce the minimum slab thickness to 140, 130, we have gone for monostrand, first time used in India in residential construction. And this is another project where the cost of construction is minimized with the management, construction management, where the overall cost completed is 950 rupees per square feet. So this is the residential villas that is happening right now with the sustainable features incorporated. And this is also ongoing construction in progress. Conventional construction, but optimized in terms of elements. And this is also a regular conventional project. And this is another interesting project we did in Bangalore. About 2 million square feet completed in 30 months with a 20-meter deep excavation into the rock. And 4 basements, all basements with the stack parking. That means to increase the parking, you know, IT buildings, we have to provide 60% of the built-up area for parking. And that we have accommodated in just 4 basements. And with the total 10 floors of this one. And there we have used the post-tensioning for 11 meter by 13 meter grid slabs. This is another project where by using PT we saved steel by 60% almost in the large span IT building. This is another 120 acre project where we have mixed development with the long-term project management we are doing for last 20 years. Various facilities in the same project. And this is in Vizag IT Park. And this is Bhubaneswar IT Park again for the same client. And this is in Pune, this is in Noida, where fixed cost, design and build contract was given. And we have done the civil structure and project. And in Pune, first time we have used the table form in office building construction, wherein we could achieve the cycle time of construction about 6 days per floor. And 2.5 lakh square feet completed in 3 months, the structure. That is the advantage of table form that we use. And Nagpur, this is a slope construction. And this is a precast government office building in Vijayawada. You know, when AP was separated from Telangana, in AP they wanted the government offices quickly. So this building was constructed in 12 months' time, 2 lakh square feet, with the quality that is not normally possible in government project. And this is a Dell facility, 6 lakh square feet, completed in 6 months' time, from groundbreaking to occupying the building. And in this, the contribution that we made is following the ground profile. The parking, we made the split parking. That means not the entire floor is not at the same level. We have done the split parking. And this is a 6 lakh square feet large span with the post-tension we have done. And this is the Amravati interim government complex in AP again, Vijayawada, which the project is completed in 6 months exactly. And here, the contribution that we made is technology neutral. That means within the same project we had precast, we had post-tensioning, we had different technologies in the same project. This is a recent project that we did in Telangana Secretariat, where the farm you can see is, in fact, it is the vision of the Chief Minister. We interacted with the Chief Minister and arrived at this kind of farm, wherein we have used the shear core in this building. The height of the building is 278 feet, the dome, tip of the dome, and this is a challenging project. And it has become most aesthetic because of the dimensional symmetry in this. If you draw the circle, they will all meet exactly. That itself will be a big topic, I will not go into that. And this is the project IT building in Agartala, where we have used first time PT in Agartala, Tripura State IT. And these are all pharma buildings in Hyderabad. Pharma is, we have seen during the pandemic where the pharma industry contributed a lot in giving the vaccine from Hyderabad. And this is right now ongoing project of IT park with about 1.5 million square feet, 19 floors, sandwich multi-level car park. This is the assembly of again AP government, and this is a university auditorium. Here we have used the spatial structure using the tubes actually. That's why I am showing this large span structure. And this is an auditorium. Though it is a small auditorium, what you are seeing there is constructed within 60 days. From groundbreaking to conducting the conference. And in this was about 19 years back. First time 10 countries are connected with conference. And each individual in the conference can be seen by all the 10 country participants. So that was the technology that was adopted. And we used complete pre-engineering in this, including the flooring of the auditorium. That is the contribution we made in greening. And this is a pavilion of a sports pavilion with a 12-meter cantilever span with a table stay. This is another interesting Formula E-Racing VVIP gallery in Hyderabad recently. This project is completed in 30 days, from planning to construction and the E-Racing conducted. This is a mall and multiplex project in Hyderabad, Bandara Hills, very centrally located. And here we have done 2.5 meter parking floor height. That is a lot of constraints on the services and the structure which we have designed. And we have used another important thing for seismic resistance sacrificial panel, first time in this building. And these are all commercial buildings and show BMW. Time being short, I will not go into smaller minor details actually. This is another interesting flatted industry in Vijayawada, which we have done in precast completely. Flatted industries in Singapore and in India, first time we did in Vijayawada to provide for MSMEs, the multi-tenant industry, MSME industries. So this is also completed in 12 months time, 6 lakh square feet. And of course, industrial projects, we all know what kind of challenges we have, combination of concrete and steel and pre-engineering. And this is an interesting project we did here for Sterlite Vedanta, where 47 meter span is done with the box section rafter and a triangular spatial purlin. So that's why I'm showing this because of the interesting shape that we have used, and it is a very optimally designed structure. This is now right now going on. This is a structure of about 3 lakh square feet with the 50 meter span by 20 meter span. And this completely we did it in Tekla right now. We delivered the shop drawings within 4 weeks for entire about 6,000 tons of steel. So this is the interesting project. This is another Schneider Electric. First time we did the roll forming at the sites with the standing ceiling about 15 years back. And this is the power plant with steel structure, STG foundation and all. And this is also power plant in Vizag. And right now the project is going on in Rajasthan, about 3,300 crore, a heat recovery project with power generation in water. And this is a FDA compliant project in Hyderabad, first time about 25 years back. And this is, even before we had these pre-engineering companies in India, we did complete pre-engineering. It's an industrial building with a dry process in this, using steel. This is another interesting project. You know, Amazon now is using ASRS, Automatic Stack Recovery System. That automatic stack recovery system we have done 28 years back in this project, wherein we use the stacks supporting the structure. So we have not wasted the material of the stack and we economize the steel here. And this is a North Light roof shell, and this is another DMIC Central Business District where we did the master planning for mixed use. And this is another interesting structure. You can see the clubhouse. That's a steel box section. And we have constructed the clubhouse on the boulders without disturbing the boulders. That's a green initiative actually. So we have stitched these boulders without doing concrete actually. We use the boulders as the foundation. And the stitched boulders acted as the raft for the structure. And we built 7-story hotel kind of structure on these boulders. And it's about 10 years old now. And entertainment and leisure also we did. And this is the leisure gallery, and the school, institutional buildings, and different forms. That's what I'm trying to show. And this is under construction now, Delhi. And this is Veda Pathsala, you know, the Vedic school, which we have done in precast completely. And though the project is delayed because of the pandemic, we didn't have any escalation, 0% escalation in the project cost, and we delivered the project with precast. This is another hostel building for Mahindra University, which we have done in precast. And the project is completed in 12 months, 2 lakh square feet, without any cost escalation. And this is the Snow World and the Snow Magic. And the steel towers, we have done about 3 lakh towers in India for all the communication companies like Airtel, Vodafone, and transmission. We have done steel structures. This is the 173 meter FM tower in Barmer in Rajasthan. And lightning towers, ISRO, we are seeing the rocket launchers where 110 meters tall lightning towers are designed, and highlight mass in the stadiums. Nowadays we are using UV concrete. And these are the runways. This is a project which we did in -30 degrees at the elevation of 13,000 feet, where we did the heating also from -30 to 20 degrees. And it's a hangar there, and runways, and reservoir intake structure. And this is another interesting project we did in Vizag, where there are 2 highways intersecting. This is a rotary management system, 3-level rotary actually. That means you have the heavy vehicles, normal vehicles, and 2-wheelers and auto rickshaws. 3 levels we have the rotary actually. So, and this is in Leh Ladakh again, near China Galwan Valley. We have done the runway and associated facilities. And finally, this is Ramanuja, the statue of equality in concrete redesign, and this is also in Vijayawada. So with this, I conclude my talk today, and all my lectures are available in my YouTube channel. If anybody is interested, you can also go back to this more in detail about all these projects. Thank you very much. I thank TATA TISCON for giving me this opportunity, and particularly Vital Rotary for giving me this opportunity. Thank you.
Thank you so very much, sir. So apparently when sir was speaking, Ratan sir, your thoughts were coming into my mind that Roti, Kapra Makan to AI to ChatGPT, from sketches to 3D models. You know what? So many things have changed. New designs, new technology. One thing which remains same is the joy of building. Yeah. And thank you so very much, sir, for giving us that joy. And sir, I must say that you're faster than the new Vande Bharat train. 60 days, 12 months. Okay, and now I would request Mr. Siddharth Mishra, COMS Tubes Division, to kindly join us on stage to felicitate sir. What an absolute pleasure we had to have you on board in our program, TISCON Grandmasters. Go on. Now I believe Siddharth sir wants to collaborate in his new projects. Thank you, sir. Thank you. Kindly have your seats. All right, ladies and gentlemen, before we move on with our next speaker, let us review a scintillating performance by Ank once again. Using the concept of water, the next most important natural element, this fusion of movement and music is an extraordinary form of expression. And the performers we are about to witness embody grace, passion,